So now we'll discuss phase difference between AC voltage and AC in series circuit, mean AC voltage and alternating current in series LCR circuit. Last video we have already discussed the impedance in series LCR circuit. The phasor diagram for LCR series circuit is shown in the figure. So according to this phasor diagram, this is the AC voltage and this is the current in series LCR circuit, and the angle between AC voltage and alternating current is phi. That means the current lags the AC voltage by a phase angle phi. Now our duty is to find the expression for phi. So according to the phasor diagram for LCR series circuit, this current and potential across resistance are in the same phase, and this AP or OD represent VL minus VC. So now in right triangle OAP, AP is called perpendicular by OA base, which is called perpendicular by base, means tan of this angle. Tan of this angle is tan phi. So in right triangle OAP, tan phi equal to AP by OP, means perpendicular by base. But AP equal to VL minus VC. AP means VL minus VC. And OA equal to VR. But VL equal to IXL, VC IXC, and VR mean IR. If you cancel out I, then it comes to XL minus XC divided by R. Therefore phi equal to, if you bring 10, then tan inverse XL minus XC by R. So this is the expression for phase angle difference between AC voltage and alternating current in series LCR circuit. So now we'll discuss the average power dissipated by series LCR circuit. So before that we have to go back. What is the instantaneous value of AC voltage in series LCR circuit and instantaneous value of alternating current in series LCR circuit? For series LCR circuit, the instantaneous value of alternating voltage V equal to Vm sin omega t, and current lags the EMF, current lags the voltage by phase angle pi. This is phi. So therefore I equal to, this instantaneous value of current, I equal to Im sin omega t, but I lags the AC voltage by a phase angle phi. Therefore sin omega t minus phi. So to calculate the average power dissipated by a series LCR circuit, first we calculate the instantaneous power. Power means voltage into current. So we have already learned that for an series LCR circuit, the instantaneous value of AC voltage V equal to Vm sin omega t, and instantaneous value of alternating current I equal to Im sin omega t minus phi. Therefore instantaneous power P equal to V into I, but V means Vm sin omega t, I means Im sin omega t minus phi. So Vm by Im, and just we divide by 2, also multiplied by 2 to make the formula. This term will be in the form of 2 sin C sin D. That's why we write Vm by Im by 2 again into 2 sin omega t minus phi. So this term in the form of 2 sin C sin D, which is equal to cos C minus D minus cos C plus D. So therefore instead of 2 sin omega t minus phi, so we can write cos C minus D. This is the C. Omega t minus D. This is the D. Omega t minus. So this will be minus omega, but minus plus phi. Minus cos C plus D. Minus cos C plus D. This is the C plus this is the D. So this part remain the same. If you cancel out omega t cos phi, and this will be minus cos omega t plus omega t 2 omega t minus phi. Therefore, average power P bar, average power is 1 by t integration 0 to t and p dt. So 1 by t integration 0 to t, p means Vm Im by 2 cos phi minus cos 2 omega t minus phi dt. So if you write this part separately, then this term is a constant, you can take it out. So it will be equal to Vm Im divided by 2t integration 0 to t cos phi dt and minus integration 0 to t cos 2 omega t minus phi dt. But the second term, 0 integration 0 to t cos 2 pi omega t minus phi dt equal to 0. But from the first term cos pi, and but this is dt. So this is dt, but this is phi. So cos phi is constant term, so cos phi we taken out, integration 0 to t dt. But integration dt mean t, but limit is 0 to, sorry, this is the capital T, 0 to capital T. So it comes to t. So this t and this t cancel out. So it comes to Vm Im by 2 cos phi. So but Vm Im by 2, it can be written as Vm by root 2 Im by root 2, because root 2 into root 2 is 2. But Vm by root 2 is the RMS value of AC voltage denoted by Vrms or V. Im by root 2 is called RMS value of alternating current denoted by IRMS or I and cos phi. And the term, this cos phi, is known as power factor. Now define the term power factor in series LCR circuit. Just now we have learned cos phi is known as the power factor. The power factor cos phi is the ratio of resistance and impedance in AC circuit. So therefore power factor cos phi, resistance is R, impedance is Z. So another very important question, explain on the basis of power factor that an ideal inductor or an ideal capacitor is wattless component. But what do you mean by wattless component? Wattless component means power dissipated by an ideal inductor or by an ideal capacitor. Wattless means power zero. Wattless means power is zero. So using the concept of power factor, we have to prove that for an ideal inductor or for an ideal capacitor, the power delivered is zero. So the average power dissipated by an AC circuit, P equal to, just now we have learned P bar. P bar equal to Vrms IRms cos phi or Vi cos phi. So for a circuit having inductor only or capacitor only, what is the phase angle between V and I? Phase angle is 90 degree. Phase angle is 90 degree. Therefore P bar, average power P bar, Vi cos 90, but cos 90 is 0. So 0. That means power, average power dissipated by a pure inductor or capacitor is 0. That's why an ideal inductor or an ideal capacitor is wattless component. So now we'll discuss another very important question, power delivered in an AC circuit having resistor only and not in AC circuit having inductor or capacitor. So what is the meaning of this question? According to this question, is an AC circuit having only resistance, they dissipated power. But an AC circuit having inductor or capacitor dissipated no power. That means power dissipated by a pure resistance has fixed value, but power dissipated by an inductor or capacitor is 0. So the average power dissipated by an AC circuit is given by P bar equal to Vi cos phi, where phi is the angle between V and I. For a circuit having resistor only, the phase angle between V and I is 0 degree. 0 degree. Therefore, average power P bar VI cos 0. Cos 0 is 1, mean VI. But for a circuit having inductor only or capacitor only, phase angle between V and I is 90 degree. Therefore, average power P bar equal to VI cos 90 equal to 0. So, now we'll discuss what is wattless current. Just know what wattless mean, power delivered by the component of current. When the component of current deliver no power, this component is called wattless current. The current in AC circuit is said to be wattless if average power consumed in the circuit is 0.